recording. And so we're going to talk about, and it's recording right now, so we're going to talk about the real numbers. All right. When we talk about the real numbers, we're going to go back to your childhood, when you were first learning how to count. And we're going to call those the natural numbers, okay? Because you did those naturally. You have these natural numbers, that's like 1 and 2 and 3. You got a toy, and you got another toy, and you had 4 toys. You started counting your fingers, okay? Now, the concept of what happens after that, the concept of not having anything at all, didn't occur to you when you were first learning your numbers. That started next, and that came up. It includes the natural numbers, and one extra number gets added in there, and that's 0. When I was talking to Ace at times, and he's doing something, and if you want to take it away as a punishment, if you tell him that you're going to have 0 of them, he doesn't completely understand nothing until he has those first somethings to relate it to, okay? So then these become your whole numbers. Okay? As you get a little older, you start realizing that temperature and money in the bank sometimes isn't always going forward 1 to 5. Sometimes it actually goes backwards, and so we keep all these numbers that we have, and then we broaden our idea of numbers, and we start getting the integers where we start going backwards now. -1, -2, -3, and so forth, all the way backwards. So we now have all the numbers from 1 to 5, and so from 0 up forever, and now we're going backwards, okay? And these are called the integers. And now we have to get some more numbers, some numbers that are, we still don't have all the numbers that we could ever use. We still have some ones in between all of them. And then, so we still have all the integers, but now we have all the numbers in between all the other numbers. So we have all the fractions, like 1/2, or 2/3, or the decimals that we write them as, like 0.5, or 0.66, and those ones that repeat, okay?
Yeah.
And so these are called irrational numbers. Now we still have some numbers that are left over that we don't have room for, and I need to kind of move over. Maybe I'll move this word real numbers over a little because I don't have enough room for it. Let's see if I can come around here. Just this part, we'll move it over because I don't have any room. I should have kept room. We have some numbers that are left over, and the way I have it drawn here, it might look like there's not as many of them because it's smaller, but there's still just as many of them. They're called the irrational numbers. I might have to really make this bigger to fit it in here. These are all the numbers that are left over, the ones that I can't express as fractions, like pi. It keeps on going forever, 314, 159, and so forth and so forth. Numbers like square root of 2. That's 1.41, and it keeps going and going and going. Now, the square root of 4 will not come in here, because the square root of 4 is actually an integer, because it can be, the square root of 4, it's a natural number, actually. The square root of 4 is 2. It actually can be -2 also, so we could make it here. That is going to be not an irrational, because it actually becomes a perfect square root, okay? So here's our real numbers. And so we're going to do some exercises here to try to decide what these are. And so if you were given -143, 473, is this a natural, a whole, an integer, or a rational, or irrational?
Oh, it's integer, right?
It's an integer, and then it's also rational, because I could write it as a fraction.
Oh, okay.
It's not a whole number, though, because so it can be more than 1.
Okay.
So it can be an integer. I'm going to just put an I for integer, and I'm going to put an R for rational. Does that make sense?
Yeah.
So let's do 2/3. What's 2/3?
Rational.
It's not, and is it an integer?
No.
No, you're right, so it's rational. What about 0.677?
Rational.
Yes, rational. And let's do 18.
It's an integer.
It's an integer. Is it a whole? Is it a natural?
It's a natural.
It is a natural, and if it's a natural, it makes it a whole. So if I were to come back over here, as you notice, I can put, 18's here, the whole numbers doesn't include just 0, it includes 0 and 1, 2, 3, 4, 5, all the way to there.
Okay.
And so, but the integers also include 0 in all of them.
Okay, so can I only choose between integer and rational, or can I choose between all of them?
You can choose from all of them. And if you choose natural, the natural includes all of them. So if it's natural, it's whole, it's an integer, it's and rational. Is it irrational?
No.
No. Okay, good job. All right. So let's do another one. Let's do 0.
It's a whole.
It's a whole. What else is it?
Natural, an integer, and rational.
Is it a natural?
No.
No.
Because natural doesn't have a...
That's right. It doesn't have 0. So it's whole. It's an integer.
And rational.
It's rational. Okay. Let's do this one that keeps going. It's 3.14.
That's irrational.
And this was, and I shouldn't, when I was using the I should have used a little n next to it. So this is IR for irrational, as opposed to IN, which is an integer. Does that make sense?
Yeah.
Okay. And what about this 1.6 and the 6 is repeating?
Rational.
Yes, rational. Okay. And then let's look at some more here. I'm going to pause this now.